this was a pivotal moment for me. I went into my first global maritime forum thinking, oh my God, I don't know anybody. Like, oh, this is terrible. I'm here alone. And 2 days later, I walked out.
You keep mentioning about the density of the fuel, right? Talk a bit more about how does that impact the bunkering hub?
I don't have a crystal ball. All I can say is I think the future of bunkering is going to look actually quite different because.
So what are the trade-offs between LNG, methanol, and ammonia? Welcome to the Schelling Point, where ideas meet. Today, it's my pleasure to have a special guest. We're going to talk very soon with Professor Lynn Loo. She is the CEO of GCMD, Global Center for Maritime Decarbonization, headquartered in Singapore. She's also a fellow engineer, although I cannot really call myself an engineer since after I got my degree, I was mostly a financial engineer. She's also a LinkedIn influencer, on which I think I have a lot to learn. So, Lynn, welcome.
Thanks for that introduction, Bertrand.
Yes, I think there's a lot of things for us to learn today. Can we start from your journey from a chemical engineering professor to leading GCMD? Like what inspired to make that transition?
Well, I mean, I think it's almost a happenstance, and serendipity plays a big role in my life. So I actually came to Singapore for my sabbatical. So this was towards the end of 2019 when, as the director of the Andluca Center for Energy and the Environment at Princeton University, we had just completed this Net Zero America study. And so I thought it was time to take a pause and learn about climate adaptation as opposed to focusing on climate mitigation alone. And Singapore, being an island nation, is very focused on adaptation as well, thinking about sea level rise. So I thought, what better place to learn about adaptation than Singapore? So I came here, got connected to the Climate Change Secretariat.
Did you have any like family member or were you in Singapore before? Anything connections?
No. But I had connections and was connected to the Prime Minister's office to talk to the Climate Change Secretariat. So it was great. And so I came and had, I don't know, maybe 2 or 3 conversations. But then because of COVID, everything shut down. So then I was forced to think about whether I go home, I stay here. And at that time, and if you recall, U.S. was kind of chaotic, so we thought it would be better for us to stay here.
Yeah.
So we stayed, and then Singapore being such a dominant player in shipping, you can't have 2 conversations without talking about shipping. So it was very easy to meet shipping folks. And so met some shipping guys and who asked me to sit on this international advisory panel for maritime decarbonization. And this was convened to think about what Singapore can do to accelerate maritime decarbonization as a whole. I was actually quite reluctant because, I know nothing about shipping, hadn't even thought about shipping, right? But they encouraged me to sit on this panel as an energy expert. So I did. And this panel met over COVID, largely through Zooms, lots of ship owners, but some technology providers, some class society was on this. And we came up with 11 recommendations for the Singapore government, one of which was to set up a center here in Singapore, given its prominence and how maritime is so important to Singapore, to coordinate efforts to think about maritime decarbonization. So that was sort of the inception of GCMD, if you will. And I wasn't quite ready to go back yet at that point because I still had my sabbatical. So I agreed to help structure what GCMD would look like as an organization. And then after that, I was very privileged. They asked me to lead it. And I thought, what better opportunity for an engineer? Because, in Princeton, I'd be teaching about engineering, but here, this is an opportunity to practice it. Yeah.
But so to me, because I actually have very similar path to you, right? So really kind of fell into shipping and completely coming from the left field. I had known nothing about shipping industry when I first started. So what was the thing that attracted you the most? Was it like the system thinking, the ship? Was it the terminal? Was it like which part of the shipping was the most interesting to you when you first started to get connected to those folks?
So you might think this is really idealistic in retrospect, but I mean, I can tell you exactly the answer to this question because I came from the power sector where
Right.
things were very fragmented and distributed, and talking across jurisdiction was very challenging. And then here, shipping is a global industry. It has one single regulator in the International Maritime Organization. So I thought, if there's an opportunity to effect change, it would be a global change. And that was really inspiring. And so it was really that idea that you can potentially have a global impact on an industry that kind of drew me into shipping.
Yeah, I see. But do you think the work you've done just before, I think you mentioned Net Zero America project, right?
Yeah.
So does that also influence how you were thinking about, is that a direct relationship? You did the project, which is more policy-based, if I understand correctly, and this one is more action-based. Is that also another impact for you to decide to do this?
Yeah, but again, I mean, so as engineers, we draw boundaries around the problem statements that we're trying to solve, right? So with Net Zero America, the boundary is America. And so it was looking at America's energy system and what it would take to decarbonize America. And here in Net Zero America, the approach was quite different from what had been done with other organizations, which is, you have an end goal and then you project or you backcast what is required to get to that end goal. And so in Net Zero America, we didn't want to do that. We said, we need to recognize what's already on the ground because those are going to be stranded assets. Those are going to be local constraints. And then to take a very granular approach to seeing what sorts of decarbonization solutions are required to get us to net zero. And with the focus being the pace, right? How fast can we move given these local constraints, given the existing policies and regulations and permitting timelines, et cetera, et cetera. So it was more taking, if you will, a less idealistic and more pragmatic approach to thinking about decarbonization. And then the other thing we did was we provided both spatial and temporal resolution for what it would take to decarbonize America, right? So where would the solar farms go? Where would the wind farm go? And if the wind farms go here, how does that impact labor distribution, et cetera, et cetera? So it was quite a comprehensive study. And so, but that, I mean, the boundary there was America.
Yes.
And so really shipping didn't come into play in that. And so shipping is an entirely different beast, if you will.
Yes.
But again, we can kind of draw boundaries around that and think about shipping and what it takes to decarbonize shipping.
Yeah, no, absolutely. And then I think last time we chatted, you also co-founding the startup in US, right, called Andluca Technology. So I guess GCMD and startup very different. I would say GSBN also very different. It's not really a startup. But can you share a bit like what are the experience you had when you co-founded this startup in US? The lesson or some of the things you have learned when you did this? Did you draw with the GCMD, and what's the difference between the two organizations?
Yeah, well, I mean, I think Andluca Technologies is a company, is a tech company, right? And there, we took a technology that was developed in my research lab at Princeton University, and so this is basically making transparent solar cells, which is in itself an oxymoron because, I mean, you want solar cells to absorb as much light as possible. Here we are having a technology that's a transparent solar cell. So it in itself is not very valuable because you're generating very little power because it's letting all the light through. But what we can do is we can then couple that with an electrochromic window like those you see in A380s, right? And so then you can use the power that you generate from the solar cell to trickle charge that electrochromic window to provide control. So then you can have basically a self-powered window is how we were thinking about it. So it's a technology company. We were trying to commercialize a technology. And with GCMD, it's a little different. It's an organization, it's a nonprofit, where I think there are common lines is you're starting from scratch. And so I think what it takes is somebody who has, you need to find a team where your team members have the conviction.
How big is GCMD right now in terms of size?
We have 22 team members.
Wow. Okay.
Yeah. But our ecosystem is actually quite large, right?
Yes.
So we have lots of partners, just like GSBN.
Yes.
And we really rely on these collaborations with like-minded partners
Yeah.
to be able to conduct the kinds of pilots we do, because we wouldn't be able to do it ourselves.
Yeah.
But I think where the commonality is in starting anything is having people who believe in the cause,
Yes.
who really believe in the, who are convicted to the mission,
Yep.
and who are gonna, in Singapore speak, it's die must do, right?
Yes. Yes.
So it's really that, and that spirit, that entrepreneurial spirit, that's sort of is what's common between whether it's starting a technology company or starting a nonprofit, is starting something and building something from scratch.
Yeah, and this regard, I think there's a lot of things I'm impressed by what you guys are doing GCMD, but the one thing I think really impressed is you're really like most like forming a cult in the sense that you're propagating your message, the cause on LinkedIn. And I think you went from very low follow count to I think now at 20,000, 30,000. And I think you have so many
Almost
posts on LinkedIn.
40,000.
40,000, sorry, I'm underestimating it. 40,000. So can you expand a bit? Because I think some people may discount that, oh, just LinkedIn. But I think in order to effect change, you do need to communicate effectively and convince a lot of people from very different horizon that what you want to do is important, right? And that's something I think you're doing much better than anybody else I've seen in the industry,
Oh, thank you.
including us. We're quite bad at communication. We try to do this podcast to do better. But can you share a bit like how did you come to do this? Like what inspiration drove you to do what you do on LinkedIn, and how did it come to be?
I mean, I think it's, again, sort of serendipity and happenstance. I mean, I had a LinkedIn account that was mostly dormant. I was kind of using it as an opportunity to kind of, basically watch what other people were doing. But it was, I guess I was inspired by one incident. So this was at the beginning when we first started GCMD. The team said, this was right out of quarantine, so still in the thick of COVID, and there was a conference, and they said, oh, this is a good opportunity for you to go and showcase and premiere GCMD. Nobody really knows about GCMD. This is a shipping conference. Go. So I said, okay, I'll go. So then I went and spoke and talked about collaborating, talked about our partnership model. And somebody in the audience basically stood up and said, this Professor Loo, she's so naive. She comes from academia. She knows nothing about shipping. Shipping is so competitive. Nobody collaborates. Everybody competes with each other. And at that moment, I was kind of shocked. I didn't know quite what to say. And so, okay, I was being nice and things like this because this is, a new community for me. But then as I went home, I was stewing about this, and I wrote this on LinkedIn, and actually got pretty positive responses. And so I think it was that gave me the courage to do more.
Yeah.
And I thought it was a really good platform to just, I mean, from a selfish perspective, it's really an opportunity for me to learn how to put things in plain speak. Because if I can put the things that I've learned in plain speak, that means I've learned it, right?
Yes.
And so that's important to me.
Yeah.
And then I think if I can put things in plain speak, then perhaps I can help people who don't really think about shipping think more about shipping. I mean, and that was me 4 years ago, because, shipping is really kind of transparent. I've before, 4 years ago, never really thought about shipping. When do I really think about shipping? I mean, when my Amazon box doesn't show up on my front door, I
when something goes wrong.
Yeah. Or when it's, when the ship hits the bridge or something like this, something very catastrophic. And so I thought it was really important to just kind of highlight the integral role of shipping and how it plays such an important role in global trade. You had said, Bertrand, that, Mark Levinson was on your podcast a little bit. I mean, I was really inspired by his book, and his book tells the story of shipping, right? I mean, and I think back to when I was a child, and we moved around a lot because my dad was transferred between countries for his job. And when we moved, my mom would try and smuggle things that we like, to the country that we would move to, because you can't buy it easily. But think today, I mean, if you want French cheese, it's easy to get French cheese. If you want French wine, it's easy to get French wine. Like, you can get almost anything anywhere. And that's really because of shipping.
Yeah.
So I think it's really important that people understand this. And selfishly, when people understand the importance of shipping, then they can see why it's important to decarbonize this industry. Because if you don't decarbonize shipping, you have no green products, you have no green solution, because our scope 1 emissions is somebody else's scope 3 emissions.
Yeah. No, that's great example. That resonated a lot with me. I think in science, what's famous is the Feynman lectures, right? When Feynman can explain something simple and such a 5-year understand, that means actually you truly understand the concept. And I think almost 80% of the job of a CEO of GSB or GCMD is people to communicate in plain language that anyone can understand and also can rally around. Okay, and I think the last question is, obviously, I think we've been working, we've known each other for a couple of years already. We're trying to collaborate together. What inspired us from your mission is definitely we agree. I think the shipping industry should decarbonize. But in our opinion, what we can contribute is we are a platform to enable data exchange, right? And part of it is the shipping is, there's two things. There's a physical space where you need to use alternative fuel or new technology, and the other one's data exchange. And the collaboration between GSB and GCMD is we can hopefully provide the not-for-profit infrastructure to enable data exchange. But I think the collaboration is you guys have the idea how to do it, and we hopefully help you share the data and prove to the customer that indeed the shipping industry is decarbonizing. That's how I view it, the collaboration between GSB and GCMD.
Yeah. And exactly. I see ourselves as being very complementary organizations. And that's why, I've been such a proponent of us working together. I think both organizations are relatively young. And so we're still kind of trying to find what the concrete ways are that we can work together. But I believe going forward, as we continue to have these kinds of conversations, there will be natural link points where we can work together. And so a couple of things come to mind, right? Fuels, as you mentioned, Bertrand, is one of them. And I think when you think about alternative fuels, we like to label these fuels green or blue or whatever, but at the end of the day, it's the carbon intensity, right? And so I think increasingly as we have lower and lower carbon intensity fuels, these aren't going to be at scale immediately. And so they will have to be blended with higher carbon intensity fuels. And so accounting for how much lower carbon intensity, how much higher carbon intensity fuels is going to be really important. In particular, I mean, this IMO, this greenhouse gas fuel intensity framework, the pricing framework has been approved, and we think will be adopted in October. Being able to account properly is going to be even more important because price premiums and emissions taxes are going to be pegged to the carbon intensity. So that's one aspect, I think, where we can work together and try to figure out how to authenticate, certify, verify, provide confidence, provide trust in the data that we have, right? And so these numbers. The other is on an energy efficiency, fuel savings perspective. So these energy efficiency technologies, whether it's wind propulsion that we're talking about or air lubrication, so these are basically blowing bubbles along the hull, right? These are technologies that can reduce fuel consumption. But I think users today don't have a whole lot of confidence to what extent you can lower the fuel consumption. So measuring, quantifying, and then being able to deposit the data in somewhere where it's not contaminated, it's not manipulated, is going to be really, really important. And so there will be a lot of data to come, and this comes with decarbonization. And so I think, again, the two organizations are complementary. It's figuring out concretely what are the first steps we can do to work together.
Yeah, and absolutely. I think, again, maybe take a very prosaic or trader point of view. To do transform, there's a lot of money have to be spent to do it. And the key thing that we want to make sure is done correctly is money is not wasted on wrong project, or people can allocate the money to the proper project. And the clear way, the best way to do that is to account for risk properly. Because if you don't know what you're measuring, that it's very hard to allocate and people just say, I want to wait until I know better before I can allocate risk. Okay. Okay, let's
That
dive.
said, though, I'm going to interrupt, and I would say, that said, I think, GCMD as an organization, by nature is risk taking because we're trialing these solutions.
You
So
have
there
to.
are going to be mistakes and things like this, but it's being able to collect those learnings in such a way that we can be better because we've done something, you know? And so how do I say this? Taking calculated risk, I
No,
suppose.
absolutely. I think you are the entity who can afford to take the risk so that the industry as a whole can move faster. And not everybody has to take the same risk. And you're the one who get only the risk. So then you're the only one who can do it. Nobody else will do that because if they have a commercial measurement or approval process, like because they're too much risk, they don't want to do it. Okay.
Yeah. Although I would still push people to take some. I mean, I think everybody has to move, right?
Yes,
I mean, if
yes.
we're the only ones taking on the risk and you remove us from the equation, then nothing's changed.
That's true. Yeah.
Right.
Yeah.
So we need to be in a place where when we're removed from the equation, things are better than they were before. Things are better than BAU or things are better than status quo.
Yeah. I think I see yourself more as lighting up the spark to take more risk.
A catalyst, right?
Exactly, a catalyst, yeah. Okay, so let's get to the crux to talk more about the specifics of GCMD. And then the first question to get everybody, the audience to understand, why is reducing carbon emission in the maritime sector really difficult compared to other industry? Because people may say, actually, it's very easy, right? It's not 10 shipping line control 80% of the volume. It should be easy just to get those guys to agree. So why is it difficult to do the maritime industry?
Well, I mean, let's put some numbers to this first to kind of just put things in perspective, right? So, I mean, shipping account for 3% of global emissions. So when you look at that number, you're like, okay, it's not that big. What's the big deal? Yeah. Well, the big deal is shipping is such an integral part of the global supply chain. If we don't decarbonize, you don't have green products and green solutions. So it's really important to work on this 3%. Yeah. And so then why is it challenging to work on this 3%? Shipping as a sector is actually quite heterogeneous. It's if you want to think about it's actually made out of multiple subsectors, if you will, because there's container ships, there are bulk carriers, there are dry bulk carriers, there are chemical tankers, and they all have very different characteristics. They go to different places. Some are on fixed routes. Some are tramping, meaning that they go wherever they need to go, kind of like taxis. Others are, on very specific fixed routes. They carry different cargoes. They're of different age. Ships typically can last anywhere from 20 to 40 years. And so depending on how old they are, whether they would be retrofitted or not is also a question. So it's a very, very heterogeneous industry. And because of the heterogeneity, it requires a heterogeneous portfolio of solution. And at the end of the day, the decarbonization solutions are actually not sufficiently mature for shipping. Where does the emissions come from with shipping? Well, the majority of the emissions come from burning fuel. And we burn the dirtiest of fuels because that's the cheapest. Yet, I mean, shipping is the most efficient mode of transporting cargo, right? So we need to move shipping onto different fuels, alternative fuels. And so what are the kinds of alternative fuels? I mean, I think today people are talking a lot about ammonia and methanol. There's LNG, which is liquefied natural gas. That's still a fossil fuel. So we see that as a transition fuel. There's biofuels, but there's not enough biofuels at scale. So let's talk about ammonia and methanol. Well, these fuels have very, very much lower volumetric energy density compared to fossil fuels. So to decarbonize shipping, there's been targets that are set by the industry. And so the targets are to reduce emissions by 20, striving for 30% by 2030, and in 70, striving for 80% by 2040. Now, to get to these goals, there have been calculations that have been done, and basically the tipping point for this is that 5% of shipping's fuel need to have zero emissions by 2030. 5%. And so we can back calculate.
Got it.
We can back calculate. Today, shipping uses about 300 million tons of fuels. 5% of that, if we assume, trade volumes stay more or less constant, is about 16 million tons. And then if we account for that energy density difference, it's about 40 million tons of either ammonia or methanol. Now, what does this mean? Today, the world produces about 200 million tons of ammonia, but only 20 million tons is being traded around the world, right? So 40 million tons of ammonia is twice how much that's being traded around the world. So I mean, the volumes are huge, right?
Yeah, yeah.
And this is what's challenging about decarbonization shipping. A, solutions aren't mature.
Yeah.
B, we just don't have those solutions at scale.
Yeah.
And C, the sector is actually quite heterogeneous, calling for different solutions.
Yeah.
So in that sense, I mean, we really need to get our act together.
Yeah.
The ecosystem needs to move. We need other stakeholders along the value chain to play ball so that we can actually decarbonize shipping.
Yeah, no, that's super interesting. I think I agree with you. The people kind of don't understand what kind of quantity of fuel has to be changed and the capacity of production. I think though, maybe I'm too optimistic, but I think if you look at what happened to solar, especially with the price going down from China, it is indeed possible. I think is it this month or last month, the stat that came out, mostly driven because I think the subsidy in China is going to be canceled, I think at the end of this month or next month. You had like a 95 terawatt that was added in 1 month in China for solar power, right? Which is just like a crazy amount of, and
yeah.
And indeed, this can happen, right? So it's not going to be discounting if the incentive as set is correct. But I think, as you said, the key thing is provided as an ecosystem, the incentives are clear. And I think here, go ahead.
Yeah, sorry. Make no mistake. I think I'm a pragmatic optimist. I too believe it can happen. What makes it so challenging is us wanting it to happen at the timelines that we've specified for it to happen. I think 2030 is really, really tough. Because permitting takes time, supply chain takes time, logistics takes time, infrastructure build out takes time. Any typical project takes about 10 years to build, right? And we're 5 years from 2030. So these kinds of volumes for green fuels is very challenging.
I think it's a classic line in technology where they say it's very easy to overestimate what can happen within 1 year, but it's very easy to underestimate what can happen in 10 years, right? So it's a time horizon, it's a big thing. But before that, I want to double click on something very interesting that you said, right? One of the difficulty also is because shipping is so fragmented, it's an ecosystem. And the value chain also is very spread out, right? Which means, if I understand correctly, is if you want to adopt decarbonization, you need to figure out who or which person you need to influence, because the impact would not be spread like equally. Can you talk a bit more about like the challenge of the ecosystem and the value chain?
Yeah. So, I mean, I think, as a chain, the chain can't decarbonize if the individual links aren't decarbonizing or aren't playing ball, right? I mean, you can just imagine being a ship owner without shipyards. Imagine being a fuel supplier without ship owners. Like, I mean, it just doesn't work, right? And I'll give you a more concrete example. So in fact, you'll like this. We just finished a pilot in China where we demonstrated, this is not fuels, but demonstrated offloading of liquefied CO2. So, and here we've unlocked every piece of the value chain. And this is the first time in the world that we've shown that you can unlock the entire value chain altogether. So it's really about bringing together the ecosystem and bringing together stakeholders. So I'll talk through this, and then you can appreciate sort of who's involved, right? So basically, this is an onboard carbon capture system that's been installed on a container vessel, so Evergreen's container vessel with Chiyao's onboard carbon capture unit. They captured carbon dioxide, liquefied it, and it's on board this container vessel. This container vessel then was offloading cargo at Yangshan port in Shanghai. And so Dejing brought a vessel alongside. And so the CO2 was simultaneously offloaded onto Dejing's vessel.
I see.
Okay. Now we've got the liquefied CO2 that's on Dejing's vessel that's going to Zhoushan port at a terminal where it then offloaded onto a truck.
Oh, wow. Okay.
And now this truck basically took it to a calcium carbonate facility where this liquefied CO2 was used as a feedstock to generate low carbon calcium carbonate. And calcium carbonate would be used as a filler material for eventually making concrete or for paper, et
Got it.
cetera, et cetera.
Got it.
So it's an entire value chain demonstrating that that CO2 that was captured on board vessel can actually be used
Wow.
for something good, right? So I mean, and you can think about fuel supply chain being
Yeah.
the same way. There are ecosystems,
Yeah.
stakeholders that all these guys need to be involved
Yeah.
in order for us to get to the end game.
Yeah, no, absolutely. I think it was last year, the Danish Chamber of Commerce organized an event in Shanghai, and I think that was when Maersk signed some agreement with Longyi or some of the
Yeah.
wind farm in Mongolia.
Yeah.
And then I had a question for someone in the panel, and that's exactly my point, which is, yes, you can do all the action, but if the data and the chain is not linked, at the end
Yeah.
of the day, nobody knows if what you're bunkering is really green or not. It could be just all a
Yes.
scam. Back in
Yes.
2010, I think Europe had a lot of green claim scam because I think the
Yes.
fraudsters made like $10 billion or sorry, euros out of those, right? So and the tracking thing is super important, and that's also the difficulty when you have such a long value chain, right?
Yeah. And so we're trying to address that as well. So in a separate initiative on biofuels, we're doing that. So we're going all the way up to the fuel supplier. We're
Yeah.
putting in chemical tracers. And so if you know exactly how much chemical tracer you put in, and the chemical tracer has a unique chemical identity, then you can follow the fuel as it comes down that supply chain.
Yeah.
And you can track the chemical tracer to know whether the volume is as specified, whether it's still that fuel that you think you bought, right, before it's being used. So it's really about increasing user confidence in that way. It's about authentication. It's about validating the feedstock origin in this case, because now we've also developed chemical fingerprinting techniques where I can tell you whether it's virgin palm oil or whether it's used cooking oil, whether it's soybean oil. So now you can differentiate between these different feedstocks, which is really important because they play a role in the life cycle assessment and therefore the carbon intensity of these different fuels.
Yeah, I agree 100%. I think the complexity with the data and the calculation, and I think to go back to what we said earlier is I don't believe one platform can play all this role. You have to collaborate. You have the classifications like DNV, which we partner also, and multiple organizations to play all their parts in this data value chain also, if you will.
Yeah. And I mean, I can see how GCMD and GSBN can come together in these things. I mean, I think, for us early on, it's been about the technology. It's been about the supply chain. It's been about the process. And now as we get more and more data, and as we think more and more about the life cycle assessment, about the carbon accounting, this is where I think we can play together and add strength where now the sum is actually greater than the individual parts.
Talk us a bit more about what you see as the incentive, the market structure, specifically for the ship owners, right? I think I recall, GCMD and BCG did a research piece back in the days, I think on the, I think it was updated recently, right? The willingness to adopt new technology. Can you explain a bit more what's the dynamics there and how those guys are thinking about taking the plunge for decarbonization?
Yeah, so I mean, we developed this construct with three archetypes, right? I mean, they're the front runners, they're the followers, and then they're the conservatives. I mean, shipping again is heterogeneous, right? And so if you want to look at the ambition for decarbonizing, there are those with ambition and capability and resources, and then there are those who have less resources, right? I mean, so if you just look at companies and fleet size, and you plot that distribution, there are certainly companies and companies very well that have many hundreds of vessels. But 60% of shipping are mom and pop owners, right? These are owners that have less than 20 vessels in their fleets, and they too need to decarbonize. They're not going to have as much resources as the companies that have 200, 500, 600, 700 vessels, but they equally need to decarbonize. Absolutely. So what we're advocating is there are different approach for different folks, and we can help front runners in different ways than we can help conservatives. With the front runners, our goal is to run alongside them and be as fast as they are And to the extent that we can lower the barriers for them to trial different things, to the extent that we can trial different things with them, we should do that. With the conservatives, our approach is if there are opportunities for us to contextualize the efficacy, the effectiveness of these different technologies and solutions, we need to do that because then we can help them and provide the data so that they can make informed decisions about their fleets. So I think different strokes for different folks. We recognize that not everybody are going to run at the same speed, and we shouldn't expect everybody to run at the same speed because there is going to be a distribution. This is why it's an energy transition and not a switch. And so we try to figure out what role we play and how we can best facilitate individual companies in their decarbonization journey.
Yeah, no, absolutely. And since we're on this subject of helping those people contextualize and understand what they can do, right? I think you mentioned already one pilot about the onboard carbon capture. Is there any other innovative pilot you're most proud of that you think had the most impact? Which one, give us a couple examples.
Yeah. How much time do you have?
Okay.
I'm proud of every initiative that we've done.
Okay.
I'm not gonna, don't make me pick winners and losers.
Children.
Anyway, so
Okay.
exactly. So I've told you about carbon capture, and I've told you a little bit about our biofuels trial. And this biofuels trial actually involved the entire supply chain. We trialed numerous supply chains with numerous ship owners bunkering at different ports, right? I mean, so these are importantly, the way we've scoped our pilots is we try to do it at conditions as close to real world commercial operations conditions as possible, because we really believe that when we step away, things need to be better than where we started coming in. If we stepped away and things go back to the usual, then we failed as an organization. So biofuels, we've done quite a bunch. We just completed a carbon capture trial. In September last year, we did a ship-to-ship transfer of ammonia. We talked a little bit about ammonia being a future fuel. And so here, the gap that we've identified is really in the transferring of ammonia. So ammonia is used as a fertilizer, is used as an explosive. It's made using Haber-Bosch process. So it's a known chemical. It's toxic. It's never been used as a fuel. And here we are talking about using ammonia as a fuel, but it's not been demonstrated. So it's a new use case. When we started as GCMD, we thought it would be important for us to do a study, a comprehensive study, to see whether really ammonia can be used as a fuel. And so use here, when we looked and dissected the industry and the efforts in the industry, certainly there are folks who are focused on engine room safety, folks who are focused on developing the engines. Where we saw a gap was on bunkering. So transferring ammonia as a fuel, so refueling essentially. So we thought it would be important for us to come in and fill the gap. So how do we address safety concerns during bunkering? What are the operational procedures for bunkering safely? And in the event of a spill or a leak, what should the emergency response be? What kind of training is required so that we can familiarize crew on handling ammonia? So that's been our focus. And so this trial that we did at Pilbara, we brought 2 gas carriers together and we transferred 4,000 cubes, which is about 2,700 tons of ammonia from one vessel to another. And we chose this volume because this is meaningful bunkering volumes. We did it at bunkering, at flow rates that are representative of bunkering, so about 700 to 800 cubes per hour. And we worked with safety authorities, consulted with the ports, worked with ship owners, worked with ammonia suppliers to make sure that we got all the protocols and all the procedures right. And then we basically conducted and executed one of these trials to show that it can be done safely. I was on board. We all had ammonia detectors to measure ammonia concentrations. And it was exhilarating in the sense that, we're demonstrating for the first time. It was out at Anchorage. And watching this happen in real time, it was incredible. And I think, there's nothing like showing people it can be done because since then, right, another pilot has been done. So this one at Rotterdam that used exactly the protocols that we've used, but they've done it at birth, basically. So incremental changes, and that's required to be able to deal with the safety and the risks and how we think about ammonia. And Pilbara ports today, their strategic plan for their next decade or so has ammonia featured prominently in their strategic plan, in part because we've done this trial and we show that it can be done, right? So again, this idea of being a catalyst and showing the world that it can be done so that people can come in and do more. And that's what it takes.
Yeah, no, I agree. I think that's also something that we learn in the blockchains or whatever, the digitization space, right? There's a ton of people doing POC, and I agree with the percent. The point is not to do a POC, but rather do something that has a chance to be in production, running production. Otherwise, you're just running around doing POC, and there's some people just doing POCs to make a press release, and then three years later, nothing has happened. so I think that's actually very important. Otherwise, some people get disillusioned also because they feel that there's nothing can be done. It's just a bunch of PR, marketing, etc. So I have to say the post I think your marketing intern did with the short, I think it was TikTok that she took, that you took the video and then she put it, was very entertaining because I think I watched those videos. I don't know what was going on, but it was very entertaining. Okay. Besides the pilots, I think you mentioned earlier also regulation is very important, right? So we can do all the pilot we want. At the end of the day, this industry is a global industry. We need some rule change in order to impact everyone. And then the most important organization in the maritime industry is the IMO, International Maritime Organization, I believe. And I think they have those regular meeting called MEPC. The latest was MEPC 83. And there has been massive conversation and alignment, as far as I understand, from not having those meetings. They kind of agree on the carbon levy and the fuel standards and tax effectively. Can you share a bit more, first off, what exactly was agreed? What's your opinion on it, and what you think the likely impact on the industry going forward?
Yeah. I mean, so it was that MEPC 83 meeting was historic, right? And I mean, my team was following it, so you can kind of, it's cast, right? I mean, it's cast online, and so you can follow it. And so my team was following it here. I was in the States teaching, and I was following it there because a lot is on the line. We have these targets. How are we going to achieve these targets without, I believe in carrot and the stick, right? And so you really need the stick. And this is sort of how we should think about it. So it was a historic moment when this IMO greenhouse gas fuel intensity pricing framework was approved. In fact, it's the only, as I know, globally sort of approved framework on carbon pricing. So it's really a historic moment. Now we're all waiting until October for it to be formally adopted, in which case everybody has to comply, right?
Wow.
And this is actually, if you look at the framework, it's quite clever. It has both elements of a carbon price, and then it also accounts for this market dynamics. So really, the IMO framework is the two jagged lines, right? There's the direct compliance target and there's the base target. It basically says the carbon intensity needs to be lowered year over year, and that's what the steps look like. And so everything is referenced to 2008 baseline. And on the y-axis, what's plotted is this fuel intensity. And so what it is basically looking at the grams of CO2 that's emitted per megajoule of energy that's being used. So different fuels have different GFI. So on the right-hand side, you can see VLSFO. So that's the very low sulfur fuel oil. It has a very high GFI. And then B10 is if you blend 10% biofuels, you lower its GFI. If you blend 24% biofuels, you further lower the GFI, et cetera, et cetera. So that's a ruler for the different kinds of fuel. So what's unique about this framework is really the direct compliance target and the base target. So if you were to use a fuel whose GFI is below that of the direct compliance target, you pay nothing. In fact, you can actually earn surplus units, Okay, so that's in the white space.
Got it.
If your GFI is between the base target and the direct compliance target, you pay $100 a ton of CO2, depending on what your GFI is. Okay. And that $100 a ton is basically, if you want to think of it as a carbon price, that's the minimum carbon price.
Got it.
And so that money then gets accumulated and it sits basically in an IMO administered fund. And there have been proposals on what we would use this fund for. It's to use to kind of supplement the green fuel premium, to help build out infrastructure, but also to help developing nations and developing countries to kind of shore up decarbonization as it has to do with shipping and and maritime decarbonization. Now, if your GFI is above that base target line, then in addition to $100 a ton of CO2, you pay that $380 a ton of CO2 equivalent.
So you pay $480.
That can be, so it would be 180 for the difference of GFI between the base target and the direct compliance.
Got it.
And then whatever's above the base target, you pay $380 a ton.
Oh, wow. Okay.
Yeah. So this $380 a ton, you can pay into this IMO fund, or you can buy these surplus units. So then this market dynamic then comes in, right? So that's why I say it's a blended framework. It's got this carbon pricing, which is this $100 a ton. And then it's got this market dynamic where you can trade surplus units to kind of take care of this tier 2 penalty.
Right.
So that's how one would think about it. So we think the surplus unit would, I mean, if the market works, right, the price of the surplus unit would be about $380 a ton, right? If it's significantly cheaper, people would buy it and cover their tier 2 penalty. If it's significantly more expensive, nobody's going to touch the surplus unit. So it'll be around $380 a ton.
And
so
what's
that's
the
how
reward
we should think
units
about
at
this.
the bottom? The reward
right.
units.
So that's if you were to use very, very low carbon intensity fuels like green ammonia, methanol, et cetera, et cetera. And so you can see that down there. And so the reward units have not been determined, but if you were to use this, you would get paid to use this. And so presumably this reward unit would come from that pot of money that's going to be accumulated at the IMO. And you can estimate how much this pot of money would be. So again, 300 million tons of fuel that's being consumed every year. A ton of fuel produces about 3 tons of CO2. So it's about $10 to $11 billion annually that you would be able to collect if the fuel consumption stays at the rate it does, right? So it's a lot of money from some respects, but it's not that much money considering the fuel transition that you need. So when people say, oh, is it big? Is it small? I think it depends on the perspective. It's a lot of money if you look at $11 billion, but it's not a whole lot to support the entire transition.
Now, this is really interesting because it creates very interesting market dynamic. I can imagine like some of the guys like the Maersk, the CMA or the Costco who bought a lot of dual fuel for dual vessel. Suddenly they have incentive, they have reward units. So they're willing to potentially even they can cover the differential between the dirty and then the clean fuel.
Right.
And then the trading, that's going to be super interesting also to watch.
Yes. I think there will be some arbitrages, some trading. I mean, the interesting thing is, I mean, LNG is okay for now, right? Okay for now. But in 2028, we calculated, I mean, you'd have to pay, or in sort of 2030, you'd have to pay penalties because you can see the GFI is 77 and you can see when it hits 77, right? VLSFO in 2028, I know that number in my head because I just looked at it. If you assume the fuel itself is $500 a ton in 2028, including penalties, the effective price is $1,700 a ton. Right. So I mean, this also shows that the fuel transition is highly inflationary. I mean, that's true on the land side, on shipping side. I mean, this energy transition is more expensive because we're trying to price in pollution.
No, it has to. I mean, there's no way you can do that without be mistake to think it's not going to cost. The other thing that's interesting, I do like also this framework because you have a predictable pattern of decrease or increase, which means you can make investments. So some investment doesn't make sense today will make sense in the future, right? And then you can load the ARR of those investments, then start to be financeable. But if I hear this correctly, also what that tells me is today a lot of shipping are buying LNG ship, but eventually because the curve going down, over time, it makes less and less sense. You have to switch either to, I see. That's very clever,
Yeah,
actually.
I
That's
mean,
very
I
clever.
think, yeah, so I mean, so the order book for LNG vessels today is as big as the global fleet of LNG vessels on the water.
Yeah,
So then we need to think about how to transition this fleet of vessels because, I mean, LNG is, so long as you're willing to pay the penalty, I suppose it's okay. But I think this is why people are talking about this LNG to bio LNG pathway, right? So bio LNG would be significantly lower in GFI, but bio LNG is limited in scale. So then the question becomes, how much would bio LNG be when everybody is after that limited amount of bio LNG, right? The other thing that's interesting here is, I mean, okay, first I should say that, you know, with this, I think, in my opinion, here, this framework is enough to signal demand, right? So it's enough to signal demand, but I'm not sure it's enough to signal supply. Supply takes time to build. So, and then if shipping were the only off-takers, I'm not sure. So because the volumes, I mean, it's large when you think about shipping, but it's not that large in the large scheme of things. So I think it's enough to signal demand. I don't know whether it's enough to signal supply. So that's one thing I think we should keep in mind. The other thing we should keep in mind that's interesting from this framework is, you know, solar and wind are treated as energy inputs. What does that mean? That means that if you use solar and wind, you don't treat it as you're just reducing fuel consumption. Therefore, the amount of fuel you use is lower and you multiply by the same GFI. With wind propulsion, you can actually reduce the GFI.
Right.
So if you, and so what that means is you have a disproportional impact on the amount of penalty you pay because the penalty goes from 380 to 100. So let's say, I'll give you a concrete example. You're on a VLSFO vessel and you have 5% fuel savings with wind-assisted propulsion. That 5% savings, that 5% fuel savings can translate to 50% penalty savings because it will drop you from the 380 category down to just the 100 category because of that 5%. So, so there are interesting dynamics that one can think about with this framework. Yeah, so I think it would be very interesting to see.
The feedback, do you know what that makes me think of? That's literally the type of thing for financial engineers.
Yeah.
Because there'll be a lot of optimization. And no, okay, the good thing is I do think this will provide impetus to invest, right? Because it tells you that if you stand still, if you stay still, you just have to pay those penalty. You don't want to do that, right? The problem I can think of also is there may be situations where you have smart people. Like, I'm not saying I would do this, but if financial engineer comes in to find arbitrage, and they may do stuff that comply to the letter of the rule, the constraint, but may not actually solve the problem. Meaning you find a loophole or some smart way to do that. So that can actually lead to this kind of consequence. In my experience, it always happens because when you set up a rule like this. But I think it's interesting to watch how that's going to develop. And eventually, I think IMO will revise the rule, right? If they realize there be some mistake in the planning, they will always change the thing later on.
Yeah, I hope so. I mean, I think this is just the beginning. And I mean, again, when people say, okay, is this significant? Is this insignificant? I think it's significant in the sense that it's historic. It's a landmark. Nobody's done this. This is going to be done on a global scale if it's adopted in October. Is it big enough? Well, I mean, it depends. It's certainly not as big as our ambition. It doesn't get us to net zero. But it's a start. And I think it's an important start. And we just have to start moving.
No, I agree with you 1%. I think it's always the hardest thing to start, right? It's not perfect. There may be potential abuse of it, there may be deficiency, but as long as we're willing to start and not to amend and change, adapt over time, it's fine. And I think you're right. The hardest thing, and that's why I think this is really exciting, it's a global scheme. Because if it's just one country, it doesn't matter. It's not going to work. Globally, I think that's probably also the reason it was so hard to get to agree, right?
Yeah.
Oh, that's really exciting. Okay, so that actually brings me to another question, which is very interesting. So I'm going to explain how I view it from someone external, right? Sometimes when I listen to people talk about alternative fuel, it feels a bit like the movie Mean Girls, where people are comparing different fuels. This one's bad, this one's good, and then spraying I think in the expression is like a FUD. That's in the crypto world. FUDing meaning you try to spread fear about different fuel. Can you walk us through a bit more? I think both there's multiple dimensions, right? One dimension is availability, price, the actual impact, but also the risk of using it, right? You already mentioned ammonia is very dangerous, but it's not something that's absolutely unsafe that we can find a way to make it safe. So like, what are the dimensions of let's say the three main that you just mentioned, LNG, methanol, and ammonia? Feel free to add any one I'm forgetting, maybe biofuels.
Yeah.
Like, what are the trade-off between all those different pathways?
Yeah. So, I mean, I think, look, if you look at aviation, they're not talking about different kinds of fuel. They're just talking about sustainable aviation fuel, Jet A1. And then they're looking for substitutes for Jet A1, right? Shipping is different because it's a very heterogeneous industry. And so the needs are different, and accordingly, the solutions will be different. So for example, when it comes to ammonia, our opinion is that container ships are unlikely to be the front runners with ammonia. Why? Container ships go to ports, they're in busy cities. They go in and they want to come out immediately. They want to unload cargo and do a million other things at the same time. Lots of port operations, people around this. And so the safety concerns around this and the safety receptors around you are high. And so it would be a really high risk to start using ammonia. I'm not saying they won't ever go to ammonia, but they're probably unlikely going to be the front runners with ammonia. We think the front runners for ammonia are vessels that go from point to point, limited number of people, vessels that go point to point where there is both cargo and ammonia. So that's why we're focused on this iron ore route between Western Australia and Northern Asia, because there happens to be ammonia, there's iron ore. Pilbara is the largest iron ore exporter. It's now already producing 5% of global tradable ammonia. It's gray, but they're transitioning it to blue and green. So there's ammonia, there's iron ore. It's on a bulk carrier. It's going to go back and forth. It's point to point. It's predictable. So we think that's going to be one of the front runners in terms of routes that can happen, right? So again, different strokes for different folks. Methanol as a fuel, it's a liquid. In fact, methanol being used as a fuel has been demonstrated probably 2 decades ago, right? This is with the Stena Germanica, which is this ferry where they had used methanol. The challenge with methanol is, I mean, I think e-methanol from a supply side, I think will be challenging because if you look at, other fuels, LNG or ammonia, there are other use cases that call for the production of these fuels. With methanol, with e-methanol, the dominant end use is probably shipping. And so then the question is whether there's enough demand to pull in all that supply, right? So there are challenges. I mean, the challenges are different, but they all have challenges. I think from a safety perspective, methanol is relatively safe because it's a liquid. We know how to handle it. From an infrastructure perspective, it's easier than dealing with a gas or a cryogenic gas at that. But I mean, let's not underestimate human ingenuity, right? I mean, we figured out how to do liquefied natural gas when we were looking at liquefied natural gas, people were like, oh, it's impossible because its boiling temperature is so low. It's a gas, it's flammable, et cetera, but we figured out how to do this. The microelectronics industry figured out how to use silane when silane's super, super toxic and everybody's in a clean room and there's silane piped left and right? The chemical industry figured out how to use chlorine gas safely, and chlorine is, I mean, at some point it was a warfare gas. So we know I think engineers are super, super smart people, bias aside, and we can figure out how to make things safely. So long as we respect the molecule, we understand its characteristics, we can engineer ways around it.
And another question that's much more prosaic, price-wise, which one you think will be long-term, in your opinion, the unit cost will be the cheapest? I think it's probably ammonia, right? If you look at...
It's we're not the only ones that think so, but I agree. We think it's ammonia.
Yeah.
And it's very simple. It comes down to chemistry. Ammonia requires hydrogen.
Yeah.
And so the green hydrogen, right? That's going to be the expensive piece because you
Yep.
need the renewable energy,
Yep.
and then you need the electrolyzer to generate the green hydrogen, and then
Yep.
it's Haber-Bosch to make
Yep.
ammonia.
Yep. Yep.
Methanol, at the end of the day, will require the hydrogen too. But on top of
The
that,
carbon.
you
Yeah.
need a zero source carbon, right?
Yeah.
A zero emission source carbon. So
Yeah.
it has to be either biogenic carbon or some recycled carbon of
Yep.
some sort. And
Yep.
so that's going to add cost to it.
Yep.
And at the end of the day, the volumetric energy density is, methanol is slightly higher, but just slightly, right? So, from that perspective, from a per unit energy perspective, ammonia is going to be cheaper than methanol.
And so I think you keep mentioning about the density of the fuel, right? Talk a bit more about how does that impact the typical bunkering hub? Because I think right now, if
Yeah.
you use it and the size of the ship, that's
Yeah.
one pattern of bunkering. The new
Yeah.
bunkering with fuel will be different also.
Yeah.
Right?
So, I don't have a crystal ball. All I can say is I think the future of
Yeah.
bunkering is going to look actually quite different
Yeah.
because of the energy density, assuming that the global fleet will largely move towards methanol and or ammonia.
Okay.
Because the energy density is so different. It's about 2.2 times lower than fossil fuels. Okay.
Right.
So what are the implications? So when we did this survey with BCG, we asked ship owners and operators, because of this energy density difference, would you basically carry more fuel, which means you carry less cargo, or would you bunker more frequently? And 60% of our respondents said they would bunker more frequently. So what does this mean? If you look at today's bunkering patterns, it's actually kind of centralized, for the lack of a better word. So, I'll give you some statistics, right? So Singapore is the world's largest bunkering hub.
Yeah.
We already said the world bunkers about 300 million tons. Singapore alone bunkers 50 million tons. So the bunkering volume in Singapore is greater than the next 9 bunkering hubs combined, right?
Wow.
So it's very sort of aggregated. People come to Singapore to bunker, right? So what does this mean when the energy density is lower and people want to bunker more frequently? This means there needs to be new ports capable of bunkering these different fuels elsewhere. It's going to be less centralized, more decentralized, more distributed, if you will, right? Simply because of the energy density difference. That said, right, we just talked about safety, and ammonia is toxic. So then I think we need to up our game on safety. People need to be better trained so that accidents don't happen, or we minimize the chance of accidents happening. So all these need to be taken into consideration. I think, on the plus side, it's a huge opportunity to upskill, those that are involved in shipping, seafarers, crews, operator. On the land side, on the ship side, it's a huge opportunity to do that. But on the other hand, it's a steep learning curve. We need to make sure we do this right.
So I think that maybe the question, I want to double click a bit what you said. Depending on the type of fuel, there's also different type of route or different type of shipping rather. Can you talk a bit more why actually ammonia makes more sense if it's point to point compared to something that keeps going on the
path? So sorry. So I should have explained this. So we don't think ammonia is going to be available at every single port.
I see.
Okay. And so if it's point to point, and these are big ports, or they have ammonia in the proximity, they can offer ammonia.
Got it.
For vessels, they're on tramp service. So they basically don't know which port they're going to, and they're like taxis. They go to wherever they need to go to. Well, if the port doesn't offer ammonia, then they wouldn't be able to bunker ammonia. So that's the challenge, right? Unless you carry a lot of fuel, or you go to ports that actually carry the fuel that you need. And remember, it's not like, I guess even cars, this is true. Different octane, or if you're using gas, you can't just switch to diesel because your engines don't work on diesel, right? And so if you have an ammonia engine, you can't just put in methanol, for example. So I think on tramp, it presents a big challenge for them, because they can't predict where they go.
Right.
And so they don't have certainty on the fuel availability at the places that they would call.
And actually, that's an interesting one. There's one question also I have. So let's say ammonia is we can produce in a certain location. I think we'll go
Sure.
later on why, for what reason it's easier to produce a certain location. But you don't think there'll be a market for moving ammonia from one port to another port? Because let's say the port wants to potentially attract more type of ship and to offer this form of bunkering, if it indeed is the cheapest and more
This
people
is a
adopt it.
really good question. So, I mean, I don't, I've done this I've done this back of the envelope calculation, and basically it comes down to the energy density, right?
I see.
So let's say you have a VLAC, so a very large ammonia carrier that's bringing ammonia, and typically they would burn their own cargo as fuel
Right.
as they go. Because the energy density is low, they're going to burn more. And by the time they get there, there's less that's left over. And then whatever's left over is going to be able to bunker less number of vessels, if
I
you think
see.
about it, because the energy density is lower. So what this means is that per bunkering, the logistics cost is actually higher compared to fossil fuels.
Got it.
The one example that I remember doing the calculation for is if you have a VLCC that's carrying crude from China to Singapore, okay, and you estimate how many bunkerings it can do. This, of course, assumes the big size ships and things like that. It's a very crude estimate. So one shipment can bunker about 30 vessels.
Yeah.
But if you bring ammonia from China to Singapore, and this VLAC uses its cargo to bring the ammonia to Singapore, by the time it gets down to Singapore, and the ammonia that's available, because of the low energy density, it would be able to do 7 bunkerings.
Wow.
7 or 8, give or take. So there's a big difference.
I see.
Okay.
And then the cost advantage will disappear effectively. Okay, wow.
Yeah, so
Wow,
I
wow.
think there's a huge advantage to being close to ports.
Got
That's
it.
why we're involved in this initiative called the Clean Energy Marine Hubs.
Yeah.
This was started by the International Chamber of Shipping with
Yeah.
International Association of Port and Harbors,
Yeah.
basically saying that we need to pay attention to both transport and energy, and they're linked together. So to the extent that you can co-locate ports with fuel production facility,
Yeah.
you want to do that because it simplifies logistics, it lowers costs, you have an opportunity to aggregate demand, aggregate supply, all those things come in. And so there are countries that have signed up for this initiative, and we are, I guess there are a number of supporting organizations now, but originally we were the shipping side, the only supporting organization. And then IRENA was on the energy side, the supporting organization. And this is really important to, have coordination at the ministerial level.
Yeah.
Because that's where the conversation needs to happen, right? Energy production and ports.
No, that's super interesting because historically ports were located close to, obviously, if you have deep water, right? So you have the physical infrastructure to build the deep ports. But then also because of that, then you have the production that's next to ports of manufacturing, right, to the export. But now what you're saying is potentially what will happen, another very important factor is where can you create this green fuel closely, and that potentially will advantage some location compared to other location, which then change the decision and how you design the network. Oh, that's super interesting. Okay.
Well, I mean, I think there are other decisions at play too. Certainly not just the cost, but I think this is a new factor, if you will, that will come in. I mean, it's true for captured CO2 too. I mean, our most recent pilot shows this. So, so our pilot, we had to find stakeholders to unlock that value chain, and the stakeholder, the end user that we found, is in Inner Mongolia. So 2,200 kilometers from where we offloaded that CO2. Because it's the first time we're doing it, we said, hell, we're going to do it. We're going to go. So the truck traveled 2,200 kilometers to the facility. But like in actuality, if you do carbon accounting, does it really make sense to truck your CO2 2,200 kilometers to make calcium carbonate? Probably not. So hopefully, these things show people what is possible, but it also highlights the challenges and the bottlenecks so that, people take these challenges into consideration as they think about scaling up, or as they think about investing in facilities, or, project development, et cetera, et cetera.
That's super interesting. Because I think, then it's just another dimension to make decision how to do this. In the past,
Yeah.
it's just about if you have a deep water location to
Yes.
be able to build a
Yes.
port, container port. But now
Yeah.
energy availability is becoming important also.
Yeah. Yeah. Absolutely.
To double click on this, I think there's one thing also that's, I think I talked about this earlier, right? Which is, I've been following this, which is the decarbonization, especially in China, has been tremendous, right? And China also happened to be a very large shipping nation, right? Along with the Greeks and then the other locations. What's your take on the current situation in China in terms of decarbonization, specifically focused on maritime?
Specifically for maritime. I mean, we are increasingly, we think, okay, first of all, we think it's important to engage with China and to work with China simply because of what you said, right? China is the largest ship owning nation. It's also the largest ship making nation. I mean, it may basically built more than 50% capacity of the ship last year and the year before. So I think it's really, really important to engage China from a shipbuilding perspective, right? I mean, I think this is where there's an opportunity to put in decarbonization solutions at the get-go when you're building the vessel. So that's really important. From a decarbonization perspective, I mean, I think we should really watch closely fuel production in China. It's super interesting. Things are moving super fast. Like you said, solar, wind, all that's growing at a really rapid clip. And because of that, and because the government is encouraging fuel production, green fuel production, a lot is happening. Very, very dynamic. I went in March to see a green ammonia production facility. And this is a company that was really heavily invested in wind power initially. And
Whereabouts was it?
This is in Inner Mongolia.
Inner Mongolia. Wow. Okay.
Yeah. And so they're producing green ammonia already. So 20,000 tons currently, and they're going to scale at the end of the year to about 300,000 tons.
Wow.
And then, I mean, what I saw was sort of phase 0. They've planned everything, phase 1, phase 2. It's very thoughtfully planned out. So I think we really need to watch this space closely, but also I think it's an opportunity to work together and to think about, I mean, right? Because of the way it's structured, because of the way China is structured, I think if there's directive from top down, things are going to happen and things are going to happen fast. And there's an opportunity, a real opportunity for China to lead in this perspective. So very, very exciting.
Yeah, that's my feedback also, is I think because of the scale and also the availability of engineers, right? And my also reflection last time when I had those conversations with the people who are in the wind or solar, it feels like as an industry, they're just running out of things to do, right? The cost is so cheap, then they have to find new way to deploy the asset that they've developed into other things. And halfway, the conversation kind of felt like maritime seems like this huge demand coming in where people would want to have those alternative fuel and they can deploy all this asset that they've invested and they've perfected. And I think that's pretty exciting.
Yeah. And I mean, I visited 3 or 4 ports in my short trip there, and it was, people were eager, wanted to learn, wanted to share. So we're continuing to explore and strengthen our partnerships there.
That's great. And I think as you highlighted, I think, I'm with you. I think it's exciting to see what's happening in China, and hopefully that will give us the momentum to even grow faster. Now, that brings me to another question, which is, I think, it's not a question I'm asking to pick which children you prefer the most, but you are based in Singapore, right? You've with GCMD, I think there's a Merce McKinley Center in Copenhagen. The Global Maritime Forum is there as well. DNV is in Oslo. And now we're saying the cities in China also, or port in China, that try to build this ecosystem. My impression why some location is really good is, let's take an example, the Northern Europe, right? They actually have all the ingredients, right? When I went to Oslo, it's clear. And when you know Shipping Conference, it's also clear. But then I think the question I'm getting at, what are the key elements you think you need to kickstart the MVP of a successful decarbonization, maritime decarbonization hub?
Yeah. So, I mean, I think I may be biased, but I mean, I think Singapore is a very, very good example, right? I
Yeah.
mean, because of its prominence in shipping, and that wasn't built overnight, right?
Yes.
I mean, I think if you look at Singapore, you kind of have to import everything, right? From talent to everything else.
Yeah.
And here, I think they've worked really hard to make sure the services are good. So from an operations perspective and a commercial perspective, you're price competitive, your services are good. People can come in. It's known as a catch-up port. So if there are delays in routing or whatever, coming to Singapore is reliable. So from a shipping perspective, I think from a services perspective, that's good. I think for us being here is because, there are many ship owners and managers and operators that are located here. And so it's easy to have those kinds of conversations. So building a critical ecosystem is really important. So, I mean, I think it's all of the above. Financial services are equally important, right? I mean, so not just the banks, but I think insurance, having access to people that you can talk to. And then it's building up an ecosystem of ship owners who are like-minded but different, right? I mean, so diversity, there's strength to diversity, but there's also that you need a critical mass, right? So I think all of the above is important. I think it's an ecosystem. It's an ecosystem thing.
So if I hear correctly, there's actually a short list of cities that can do this. It sounds like potentially you can have Shanghai, you may have Hong Kong, you may have London. Actually, London in the past was pretty big with insurance, right?
I was going to say, yeah.
New York, maybe, because you do have. I think it's not as strong before. So, but that's in your mind the starting point that you need to have, to dominate this.
So I think, look, London, I would say as a shipping ecosystem or a shipping epicenter or a shipping hub, as you would, is sort of a thing of the past. I mean, I think there's still financial services, insurance, et cetera, in London. But I mean, I think there's less actual shipping activity in London. Right? I mean, you don't think of it as a port that people go to.
The only thing they have left, I think that's very strong still,
is financial services.
Finance, and then the lawyers and the legal system. That's very important for adjudication.
And New York is the same. I mean, New York, I mean, we think of people listing in New York, but I mean, and the US itself, I think shipping is almost decimated, right? I mean, so I don't know how to think about New York, but I do, when you were asking, I was thinking about hub around the world. I mean, I think the Gulf is pretty interesting.
Yes,
because there's
Dubai,
right?
Yeah.
And even the Gulf of Mexico is pretty interesting. I mean, there's going to be energy production. I mean, who knows how fast, how whatever, but I mean, there's energy production there. There's a lot of shipping activity there. Could that be a shipping hub? That could be interesting.
No, I think should I break the next question? How can the maritime industry attract more investment talent to accelerate decarbonization effort, right? Because fundamentally, you need engineers, you need smart people to put their heads around the problem. So what's the three things that we need to do to accelerate, to attract more talent?
Well, I mean, I think first and foremost, people who can showcase how important shipping is and how exciting shipping is should do so. I mean, I think shipping is it's a really dynamic community, and it's a community that has a lot of heart. I remember coming in as a stranger, right? And this was a pivotal moment for me. I went into my first Global Maritime Forum thinking, oh my God, I don't know anybody. Oh, this is terrible. I'm here alone. And 2 days later, I walked out and I'm good friends with everybody, right? I mean, and it's a community that has a lot of heart. And so I think we really need to showcase that and tell students about that and make it obvious that this is actually an exciting industry to be a part of. The International Chamber of Shipping had done a survey, and basically they estimated about 800,000 seafarers need to be upskilled by mid-2030s to be able to deal with alternative fuels. So so seafarers too, right? I mean, we need more seafarers. And for all that we talk about, autonomous shipping, et cetera, we need to upskill our crew. So there's, I mean, a lot that we need to do to make sure that we attract talent into the industry.
I agree with you. I think and you're right, it's not just shipping, right? So first off, if you want to hire more people, there's a lack of ability to tell the story why young people should join such a specific industry. I think if you look at the ads, everybody wants to become a YouTuber or do podcast.
Yeah.
and as an industry, typically people are not that great at telling the story. And the shipping industry is even harder, I think, for two reasons. Number one, it's very complicated. It's so complicated. What type of shipping you're talking about? And number two, traditionally, I think the ship owner or the industry is very reticent to share because they're afraid of. I think as an industry, it's more secretive, less transparent, right? But as you said, the shipping is really interesting industry. I think the more people I meet in this industry, more people like kind of be of the same pattern. People fall into shipping, and then once they're in the shipping, they don't leave because there's so many other things to do, right? And that's a pattern I see time and time again with people when I meet people who have similar background coming from something completely unrelated. And I think that's the power, that's attractiveness of shipping.
Yeah, and I mean, what does a chemical engineer do in shipping, right? I mean, but ironically, I've used more chemical engineering since I've been in shipping than when I was so.
Absolutely. I think that's also the tragedy of, I would say, the a lot of the industry over the last few decades, right? Because my background, as I said before, I was trained as a technical engineer, applied math, financial engineering. What do? I end up in finance. All my classmates end up in consulting, right? And these days, everybody go to tech. But the impact of those industry on the real life is actually quite limited, right? The industry like shipping, where you provide, as you said, right, food, the clothes you wear, the goods that you need to function, that's actually much more critical, much more tangible. And then the problem is those industries are not able to tell as good a story. Why it's so interesting. Okay. I think we're coming to the end of the podcast. There's a last question. I'm excited. Nothing to do with shipping. More open-ended. Can you tell us more about any like fundamental discovery of your research team in Princeton? Because I think half of your years is in Princeton, half of years in like, what's the most exciting thing that you guys are working on? It doesn't have to do with shipping or decarbonization, like discovery or project that you're doing, research project you're really excited about.
Yeah, so we're working on an emerging technology for making solar cells better.
Okay.
It's called perovskite. And so this is it's a different chemistry, and the idea is, with silicon solar panels, they're on rooftops today.
Yep.
Their efficiency is pretty much maxed out, very close to the thermodynamic efficiency. So if you want to make them more efficient, you can't. I mean, you're hitting the limit basically.
Yep.
And so with perovskite, they absorb a different spectrum, a different wavelength range of the solar spectrum. And so the idea is you can then, if you can make these solar cells, you can stack them on top of the silicon cell. So over the same footprint, you can increase the efficiency. So we've been working on those. And the efficiencies are actually quite good on these cells. The challenge is the stability of these cells. And so we actually develop accelerated aging experiments because, a graduate student's life is 5 years at a university. They don't want to stay for 30 years. So we came up with accelerated aging protocols, and we've tested these solar cells. And we have actually one of the record lifetimes on this chemistry of solar cells. And so the idea is to kind of stack them and make what we call tandem cells, like tandem bicycles, but tandem cells, so that you can improve the efficiency of silicon solar cells.
What's the I won't say half-life, but the useful life of a normal silicon cell?
I think it's 30 years, and I'm not even sure it's because of the silicon itself. I think it's because of all the, the sealants and things like this around the solar cell, because you've got wires and things like this. Yeah. So I think it's 30 years. So I think those are things that should be worked on too, but there's less sort of fundamental scientific discovery there. What we like about perovskites is, the chemistry is actually really, really rich. And at the end of the day, my passion is understanding structure, how structure develops. And so here, structure is on a very, very small length scale. It's on a nanometer length scale. So this is 1/100th the width of a human hair, right?
Yeah.
That's how big these kinds of structures that we're looking at
Yeah.
are, and how that translates to macroscopic efficiency and properties. So that's what we're interested in. So, I mean, when I'm at Princeton, I spend my time peering into an electron microscope. I spend my time looking at X-ray diffraction to understand the structure. We build devices, but our devices are about this big.
Yeah.
So it's quite a big contrast. And that's why when I give talks on both shipping and the stuff that I do at Princeton, I go, we're going from nanometer length scale to nautical miles. And that's like 12 orders of magnitude in length scale.
I think the Venn diagram of people who understand both is probably vanishing small. I see. Now, the reason I asked a question about the useful life is more I wanted to understand when you do this the innovation you guys are doing on this new material, right? Is it to extend the useful life so that it can match the useful life of the silicon? And therefore, you can deploy that in tandem, as you said, right? And you'll have to replace it after 6 months because the new one actually is breaking down. I guess that's the research you're doing right now, right?
No, so we want to match the silicon lifetime so that we can actually make an integrated cell that has an efficiency that's higher than the silicon efficiency because it absorbs different wavelengths of light. So silicon only absorbs really visible light.
What is the efficiency right now? What's the efficiency of a silicon cell?
21%, something like this.
And with this added component, how much extra would it get?
So the one that we have individually is a 17%, and so when you add them, it depends on whether it's not additive, right? So it depends on whether you connect it in series or in parallel.
Yeah, of course.
Because in one configuration, the voltage has to be kept the same, so you can go up to about 30%.
Wow, that's a 50% increase, effectively. That's massive.
Yeah.
So without adding the surface of the thing, it's 50% increase. So
yes.
Quite big.
And so where, like in Singapore, where landmass is, limited and things like this, I think it would be important.
Yeah. And again, imagine also if it's used on top of building and things like that, where you are limited in size, this will have an impact. If it's a desert, you don't care. You can put more solar panel. Oh, I see. That's super interesting. Okay. So we have a last question. If you could invite anyone else as the next guest on this podcast, who would you invite? Why? What do you think the unique perspective they can bring to this podcast?
Yeah, so I have a couple of names actually.
Oh, wait. Wow, okay.
Yeah. I mean, I think the first one is Fei Li. Do you know Fei Li?
Yeah.
Who is
She's
sort of the AI expert?
Of AI.
Yeah. She's a
with Jeff
professor
Hinton
at
and
Stanford.
Yoshua Bengio.
Yeah. And I mean, I think she would be fitting for your podcast, Schelling Point, right? Being able to coalesce and bring people together. I think she'd be perfect for that. And especially on an AI topic, right? That she's a leader and expert in. In shipping itself, I mean, I have a couple of names that I think would be interesting. Rolf Torre Robson, Rolf Torre Ropestad, I think is how you say his last name, who's the CEO of GUARD, who was just named chairman of the P&I group. I think we hardly talked about risk, although risk is inherent in our discussion. I think getting him to talk about risk, about how he sees insurance playing a role in future fuels, et cetera, future fuels adoption, et cetera, I think could be super interesting.
Absolutely.
So how do you come up with new risk instruments or insurance instruments to price risk, right? When pricing, when looking at coming up with insurance instruments, it's really about learnings from the past so that you can price risk. But now we're looking ahead. How do you price risk that you actually don't know what the risks are? Would be what I think would be super cool. And then another person would be a lawyer, a maritime lawyer, Harris Zogarfakis. All these have difficult last names that I can't pronounce, from Stevenson Harwood. So he's a co-founder of Blue Vixby. Do you know this? Just in time. And so from GSBN's perspective on data, et cetera, this could be interesting. And I mean, who knows? 1 + 1 could be more than 2 when you guys have a conversation.
Sure. No, we'd love to. No, thanks a lot for those recommendations. I think we can follow up after the podcast and see if you can arrange. So no, that's great. Thanks for the suggestion.
Sure.
That's it. Thanks a lot, Lynn, for spending almost 2 hours with us. Please like, subscribe, comment, and share. If you have any comment for future guests or any comment for this episode, please send us some comment in the comment section. And see you next time on the Schelling Point, where ideas will meet again.